Hello everyone. Today we will be exploring one of the most fascinating and fundamental forces in the universe, gravitation. From falling apples to orbiting planets, gravity influences everything around us. Let's dive into how this is invisible force works and why it is so important. Gravitation or gravity is the force of attraction between two objects that have mass. It's the reason why objects fall to the ground when dropped, why the moon orbits the earth, and why we stay anchored to the planet's surface. It may feel ordinary, but gravity is one of the four fundamental forces of nature, and without it, life wouldn't, as we know, it wouldn't be exist. Let's take a quick look at how our understanding of gravity evolved. Aristotle in ancient Greece believed that heavier objects fall faster than lighter ones, but Galileo Galilei proved otherwise, showing that all objects fall at the same rate in a vacuum, regardless of their mass. Then in 1687, Sir Isaac Newton revolutionized physics by formulating the law of universal gravitation, proposing that every object in the universe attracts every other object. Newton's law of universal gravitation. According to Newton's law, F equal to G multiplied by m1 and m2 divided by r square. This equation tells that gravitation force between two objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Here G is the gravitational constant where has a very small value, 6.674 multiplied by 10 power of 11. Newton meter squared per kilogram square. This is why we don't feel the pull of gravity between everyday objects. Their masses are too heavy. Gravitational constant. The gravitational constant was first measured by Henry Cavendish in the late 18th century. It plays a crucial role in calculating the gravitational force between two bodies and helps us understand planetary motions and satellite behavior. Many people confuse mass and weight. Mass is the amount of matter in an object. It remains constant no matter where you are. Weight, on the other hand, is a force which gravity pulls on that mass. So, an object's weight can change depending on the gravitational field. For example, your weight on the moon would be exist one-sixth of what it is on Earth. Then we come to weight versus mass. Mass, amount of matter, constant everywhere. But weight, force due to gravity varies with location, where W equal to mg. Weight decreases with altitude or on the moon. Motion of planets, it depends on the Kepler's law. Now let's look beyond Earth. The motion of planets in the solar system is governed by Kepler's law. Planets orbit the sun in elliptical paths. A line joining a planet and the sun sweeps out equal areas in equal time. The square of a planet's orbital period is proportional to the cube of its distance from the sun. This law, when combined with Newton's theory of gravity, allows us to predict planetary orbits with high precision. Gravity also keeps artificial satellites in orbit around Earth. Geostationary satellites rotate with the Earth and stay above the same point on the equator, perfect for TV and communication. Polar satellites pass over the poles and are used for mapping and weather forecasting. Satellite needs to travel at a precise orbit velocity to in orbit without falling back to Earth. Then if we look for the applications of gravitational force and gravitation, there are many gravitational practical applications. It helps us understand planetary and lunar motion. It enables technologies like GPS, satellite, TV, and weather forecasting. It plays a major role in space mission and launching rockets. It even affects tides caused by the moon's gravitational pull on its ocean. Thank you.